This is our last problem of the day, and then we just have a couple story problems and we're done. So once again, same process. We're going to pick a letter to eliminate. So it really doesn't matter which letter you pick, but for the sake of the videos, we're just all going to pick the same letter so that we can all have our notes on the same page. So let's do X's again. I like X's, they come first. So we have picked, we are going to eliminate our X's. So step 2, pick a pair of equations that you're going to eliminate the X's from. Really doesn't matter which pair you pick. So let's just pick the first and the second. So I picked a pair of equations. I'm going to eliminate the X's from these equations. So let's times the top one by 2 so that our X's will stack up. Then I have my bottom equation. And look at that. That is a true statement. So it seems like right now we're probably going to get an infinite solutions here. So, but we're not done. We still have to do step 3. Pick another pair of equations that we're also going to eliminate the X's from. So let's do, I don't know, let's do the second. And the third. So I, once again, need to eliminate the X's. So let's times this one by 4. So then I can get my X's to stack up. I get 4x plus 8y plus 20z equals 40. X's eliminate just like they're supposed to. And I get 2y plus 32z equals 38. So, step 4, let's look at the 2 by 2 that we have as a result of steps 2 and 3. We have a 0 equals 0, and we have a 2y plus 32z equals 38. That's our 2 by 2. Now, immediately, because we have a true statement in here, we know we have infinitely many solutions. Now, if you remember from 6.1, there's a specific process we do when we have infinitely many solutions. And that process begins by taking the last letter alphabetically, so in this case Z, and saying Z equals T. And that's our first answer. Hopefully this is coming back from 6.1. Then I'm going to take the equation that I have in my 2 by 2, 2y plus 32z equals 38, and I'm going to replace the z with the t that I got in my first answer, and I'm going to solve this one for y. So minus 32t divide everything by 2. I get y equals negative 16t plus 19. And there's my y answer. And now I'm going to take any of the 3 equations that I started with, plug in t for z, plug in that equation for y, and solve for x. Oops, that made a big giant mess. There we go. Let's try that again. Surface is being glitchy. Whoa, not that either. Okay, I guess it's fine as it is then. So let's take any of our 3 original equations. Doesn't really matter which one. I'm going to take the last one. plug in the equation we got for y, negative 16t plus 19. Plug in t for z. And then we're going to solve this for x. So we get x, let's see, negative 32 plus 5 is minus 27t. Bring everything to the same side. And I get x equals 27t minus 28. And there is my coordinate point. So the x value is 27t minus 28. The y value is negative 16t plus 19. And the z value is t. And if you remember from 6.1, I can plug any value in for t that I want, and it gives me the set of points that all of these lines have in common. So a good visual for that is right here. I have 3 planes happening here, and notice that this whole line of points is the line that these planes share. So there are infinitely many points that these planes have in common. And those points that are on that line that they all share and have in common all fit this formula right here. Now, one last thing before we end this video. Let's just remember our vocab words from 6.1. If it was an infinite solution system, we called it consistent dependent. If it was a no solution system, we called it inconsistent. And if it was a single solution system, we called that consistent independent. So there's our 3 examples of different 3x3s. We have one of each type of system. In the next video, we'll start to look at story problems using 3x3 systems.